So here's another really fundamental exercise for us to do, exercise 5. Find sine A, cosine A, tangent A, secant A, cosecant A, cotangent A for the angle A as pictured. Now it seems kind of overwhelming having to find all these trig functions, but if we recall, what we just learned is if you know sine and cosine first, you can use sine and cosine to describe the other 4 trig functions. So really the challenge here is just find sine and cosine and then take what we know about the relationship between sine and cosine and the others to describe the others. Okay. So we are going to get started by we're going to use SOHCAHTOA. But in order to use SOHCAHTOA, we need to find the missing side. Let's see, from A's perspective, this missing side, it's not the hypotenuse, it's not the adjacent side, it's actually the side opposite angle A because angle A is down here. And if I call that X, because I got 2 out of 3 sides, I can apply the Pythagorean theorem here. It's a leg of the right triangle, so 1 squared plus x squared goes on one side of the equation. 4 squared, the hypotenuse goes by itself on the other side. 1 plus x squared is 16. X squared is going to be 15, so x is plus or minus the square root of 15. It's got to be a positive root here because it's a side of a triangle, so x is the positive square root of 16. Okay, so let's go ahead and find our sine and cosine. Sine A is opposite over hypotenuse using SOHCAHTOA. So let's see, from A's perspective, the opposite side is x, that's square root of 15, over the hypotenuse is 4. And there's our sine of A. And just for the record, decimal is 0.968. So make sure you can find that if you have to. It's not required for this exercise. That's fine. Now we're going to do cosine A is adjacent over hypotenuse. And adjacent to A is 1 over 4. And of course that's just 0.25. It's a decimal. Tangent A is, now I could use the fact that sine over cosine is always equal to tangent from our I could just divide sine by cosine. Or I could use SOHCAHTOA. So with tangent, you're going to have that choice. Here, I don't want to divide fractions, so maybe I'll just do TOA, opposite over adjacent, but it'll come out the same either way. Opposite over adjacent is square root of 15 over 1 is just square root of 15 is the tangent of angle A. Square root of 15 is about 3.873. And now what do we need? We need secant, cosecant, and cotangent. So secant A, here's where you'd really just have to have this memorized, that secant is 1 over the cosine of A, not the sine. Only one co in the reciprocal relationship. So that's 1 over a fourth. Now I would just, you can divide 1 divided by a fourth, or you can just think of 1 over as meaning take the reciprocal. So that's going to be 4 over 1, or 4. The secant of A is exactly equal to 4 here. The cosecant of A is 1 over sine A. That's 1 over square root of 15 over 4, which is 4 over the square root of 15. Fine if you leave it that way. If you rationalize, you get this big mess, and that's fine too. And the decimal, I had to round off, I got 1.033. And finally, cotangent A. Now, I would use the fact here that it's 1 over tangent A. It's also cosine over sine. I could take cosine divided by sine, or 1 over the tangent. 1 over the tangent is 1 over the square root of 15. I guess I'm already done just by writing that down. Of course, that rationalizes to square root of 15 over 15. And a decimal I have for that is 0.258. Whoops. Oh, did it again. Slipped below the line. So now we can see it. Cotangent of A. And I think we're through with exercise 5. We found the 6 trig functions of A where A was pictured.